Hello, welcome back. Let's go ahead and jump into another LeetCode problem. This is problem 142, linked list cycle 2. So let's read through the description to figure out what we're doing in this problem. It says, given the head of a linked list, we want to return the node where the cycle begins. If there's no cycle, we just want to return null. So this is actually more of an interesting problem than just determining if there's a cycle, because in that problem, we only return a Boolean true false if there is a cycle in the linked list. This one's a little bit more involved because we want to know the first node that the cycle starts at, where it loops back around and connects. Let's read through the rest of the description to make sure we know everything. So there's a cycle in a linked list if there's some node in the list that can be reached again by continuously following the next pointer. So in this example, we know that this has a cycle because the next pointer of -4 points to a node that we've already visited, this to node. Let's continue reading. Internally, there's a position, which is used to denote the index of the node that's tail's next pointer is connected to and it's zero indexed. That really doesn't apply to us too much. It's just kind of an internal indexing thing they're letting us know about, but we don't really need to keep track of the position ourselves. We're not even given this position value as a parameter, so it's not going to really apply to us too much. One thing that we need to note is that we can't modify the linked list. This would actually be pretty easy if they let us modify these values, because we could just say, okay, let's figure out what our maximum and our minimum values are for these nodes. And they tell us right here that the node value is always less than this 10 to the fifth and greater than -10 to the fifth. So we could say, okay, every value that we visit, we're just going to set the value equal to 10 to the fifth plus 1. And then if we see this value again in our node, we know that we've already visited this node once before, so we can just return this node now, and that would be the whole problem. But we're not allowed to modify these nodes, so we have to find a different way to do it. So let's think through this. How can we actually make this happen? Well, looking at this example, we can see that, okay, we have a linked list here, and we know that if this node didn't have this connection, if this next pointer didn't point back to this 2 value, we would know that this would be pointing towards null or none in Python, which is what I'm using. And so if this next value is none, then we know there's no loop in this linked list because there would never be a case where we would get none as our next value for a node. So that's one check that we have is if there's ever a case where our next value is none, we can just return none. That's what they tell us to do if there's no cycle. If there's no cycle, we return null. Okay, so we have that base case figured out. Now we need to figure out how we're actually going to detect this cycle. So how can we know for sure that we're in a cycle? Well, the trick to these cycles with linked lists is we need two pointers. We need a slow pointer and a fast pointer looping through our linked list at the same time. So that means that we start off with both pointers at this first value, and this is the only time that we set them equal to each other, and then we say, okay, we're going to have a slow pointer that moves through our linked list one node at a time. And we're going to have a fast pointer that moves through our linked list two nodes at a time. So this would be going around two steps for every time the slow pointer goes around one step. And if those values ever equal each other, that means that there is a cycle in our linked list because we know that this one going faster than our slow pointer shouldn't ever connect if this just has none at the end of it. There's no case where this should be looping back and equaling our slow pointer. So that's a guaranteed way we know that there's a loop in our linked list. Okay, so that helps us. Let's see how that would play out with this example. So if we start here and we have our slow and our fast pointer right here, we would say, okay, our slow pointer moves to 2 and our fast pointer moves 2 steps up to 0. Okay, so now next step, our slow pointer moves to 0 and our fast pointer moves past -4 and back around to 2. Okay, so now we've done the cycle, but we don't know that for sure because this could just be another 2 node after this -4. So let's continue. Our 0 is where our slow pointer's at right now. That moves forward 1. And then our fast pointer is at 2, and this moves forward 2 steps to -4 as well. So now they're on the exact same node, and we know that if we do an equals check between these nodes, they're going to be the same value, the same pointer. Okay, so we've detected a cycle, but how do we know for sure that this is going to be the start of the loop? Well, we don't. This isn't actually the start of the loop. We want to return the node where the cycle begins. So we need to find a way to actually confirm that this is the start of the cycle. How can we tell that this is where the cycle started based on this? Well, it's actually pretty cool, but when we start at the head and we move forward, as soon as we hit this 2 node, we've entered the cycle, and our slow pointer is moving farther away from this value compared to the head value, which is staying like, so let me explain this in a different way. Our head is going to be 1 value away from this 2 pointer, and our slow pointer that's moved to -4 by the time that our fast pointer is equal to it, this is going to be an equal distance from the start as our head is. So we can just move both of them at the same time using these next values because we know that there is a loop. So our two pointers, the head and our slow pointer, can just follow this next value until they're equal to each other, and they'll be equal to each other as soon as we hit the start of our cycle. So let's start coding this up and figure out what's going on. So our base case is that there are no nodes in the linked list. So if we're given a linked list with no nodes, we need to make sure we handle that base case. So to start with, we want to have a slow pointer, which is starting at the head, and a fast pointer, which is also starting at the head. So we can set those both equal to our head value. Slow equals fast equals head. So now we know that we have both pointers starting at this 3, and we want to say, okay, while our fast pointer does not equal, or so in Python, while fast is actually confirming that fast does not equal none, but we also want to make sure that our fast has a next value too, because this is going to be moving 2 spaces per per loop in this while loop. So we're going to say while fast and fast.next, which just confirms that fast.next exists also. And then in here, we're going to move our pointers first. So we're going to say, okay, slow is going to move forward 1, so that's slow.next, and fast is going to move forward 2, so that's fast.next.next. Okay, now what are we checking for when we actually detect a cycle? Well, we saw that we detected a cycle here when these 2 pointers are equal to each other. So we can say if slow equals fast, then we know that we've detected a cycle and we need to start figuring out where the cycle started. So in this case, we want to move our slow pointer forward an equal amount of times that we move our head pointer, because as soon as those are equal to each other, we know that we've found the start of the cycle. So we want to move each of them until they're equal. So while slow does not equal the head, then we want to move both. Slow equals slow.next, and head equals head.next. Okay, and then once these are equal to each other, this while loop will break, and we're actually done there. So we can just return either the head or the slow pointer. They're both pointing to our start value. And then our base case is that fast or fast.next equals none, and that means that there is no loop. So when there is no loop, we're told we want to return null. So that's what we're going to do out here. We're going to return, and that's none in Python. So let's go ahead and run this and see how we look. Okay, so as you can see, it works. It has a pretty good runtime, and that's the full solution. Thank you for watching, and like and subscribe if you like these kind of videos, and I will see you in the next one.